But we're just going to try to run through some different things about the soil food web, the soil organisms, and what they do. You know, the first thing we have to understand is that soil is a habitat. You know, you talk to a wildlife biologist, you know, they say, well, you got to have deer habitat or quail habitat. And so they go through a whole laundry list of things you got to have for that wildlife, right? You got to have food, you got to have cover, you got to have protection from weather. And so we have to understand that soil is the same way. That soil is the habitat, the house, the food, the environment for those organisms. And we have to understand that we are the biggest detriment or the biggest help to those organisms with our management. Okay, and we have to understand that it's complex. You know, everybody's seen this picture, and we have to understand that there's many levels, and if even one of those levels something happens to it for whatever reason, you know, that messes the whole system up, right? So we have to understand that it's very complex, that you've got all these different levels, and we're going to go through some of them here. So just big groups, okay, big groups of organisms. We've got photosynthesizers, decomposers, mutualists. You can go on down the list here. You know, some of them, their job is to capture energy, to capture sunshine. The plants, right? But there's also other things that do photosynthesis a little bit, algae and bacteria, particular kinds. There's some that the mutualists that benefit other plants, that have symbiotic relationships. There's others, their job is just to shred and chop up plant material. There's others that are predators. Their job is to control populations that are, for some reason or another, are getting out of control. Okay? And so, while they are part of the soil, they are part of the organic, the living part of the soil, right? And so it's a very small fraction. You've got soil, you've got organic matter, which includes plant and animal material, and then a small fraction of that. And again, those numbers on the right over there, they're not meant to say that that's exactly the mix that is in the soil. That's going to vary greatly on the type of management that you have. In most cases, this is just a slide that I pulled off. The fungal versus the bacterial are probably in most cases going to be reversed. It's going to be a lot more bacterial than fungal. So where do they live in that soil? You know, they live in the spaces between the aggregates, obviously. They live in the litter, and you can call it the trisphere. You can call it a lot of different things. I don't get into too much of that. They live in and around the humus on the soil aggregates. You know, most of them, and this is why water is so critical in the soil, most of them live and move in the film of water on the particles of soil, on the surface of those soil particles. They're considered subaquatic, really. And so they have to have something that allows them to move. So that's why water is so critical. This rhizosphere, the other big zone where there's a concentration is this rhizosphere. The rhizosphere is this zone right around the root. Because as Barry mentioned earlier, plants give up to 50% of their photosynthetic energy that they derive from minerals, from sun, from water. They give it up because they know they're going to get something back for that, right? He described that system. And so that zone right around those roots, that rhizosphere, that's the zone of highest biological activity because that's where the nutrients are from that plant that it's giving off, those exudates. So what's it do seasonally? You know, obviously based on temperature. Now there are organisms, you see it never goes down to zero here in the winter because there are some organisms, they continue to respire even in the winter. They're very, very, very slow, but as temperature increases, as moisture increases, what happens to their activity? It goes up in direct correlation to that soil temperature. Late summer, why is it take a dip right here in late summer? It gets hot, somebody said. Thank you. it starts to get dry, right? And as Barry said, temperature is huge as well, right? They're just like you or I. They do their most work, about 70 degrees, kind of depends on what they are. So as that soil temperature gets hotter and hotter and hotter and drier, their activity starts to plummet, doesn't it? And that's where having the soil that is not only cool, but has good moisture, we have a good ground cover, that's critical to ensuring that biologic activity right in here, because what's happening right there? You've got plant fill on our crops, right? It's a critical time. But yet, if we don't keep that soil temperature and moisture in the right condition, it doesn't matter how much fertilizer you put on, if those organisms are not making it available, you're not going to get a good benefit from that. And then obviously, usually what happens in the fall before frost, we get another little rain or two, but the sun, we're starting to get cooler temperatures, right? So you're going to get a little flush of activity here in the fall, and then once you start getting cold temperatures, boom, they start really dropping. Where does it occur in that soil profile? Okay. Again, at the surface, this is an increase in biomass. So at that surface, you've got a tremendous amount of activity. As you go down in depth in the soil, it starts to drop off. And again, that's moisture, it's air. They're just like you and I. They have to have oxygen to breathe. So there's more air exchange at the surface. There's also more of a food source. There's more plant material. Okay. So the closer to the surface, there's more activity. So this is just, and again, this is not meant to say that this is exactly the ratio of in a different environment, but we've got a Scots pine forest, a prairie, a short grass prairie, not a tall grass prairie. We've got a no-till system and then a conventional till system in Georgia. And again, it's just it's bacteria, fungi, protozoa, nematodes, arthropods, earthworms. So in a forest, we're very highly fungal. Okay? So if you understand the difference between a bacteria and a fungi, bacteria are single-celled, very fast-growing, very quickly multiplying organisms, right? Fungi tend to be very long, filamentous, and much slower growing. So why in this forest would we have a high fungal and low bacterial, and in all of the others we have more of a bacterial dominated? What's the level of disturbances in all of these compared to this forest? A lot more disturbances, right? Grazing, tillage, harvest, a lot of different things. So anytime we have a disturbance, and if it resets that population, which one's going to multiply fastest and first? The bacteria. They're always, after a disturbance event, doesn't matter whether it's tillage, whether it's grazing, whether it's hay, a fire. They've had some big fires out in Kansas and Oklahoma. Any kind of disturbance event, you're almost always going to get a spike in bacteria after, because they can mature faster than anything else. And again, I'm meant to say that this is exactly the numbers in these different environments, but it's just to show you that there are literally thousands of pounds of organisms in the soil. So how can you measure it? There's a lot of different things out there to do that with. You can count it with a microscope. You can measure it with CO2, just like you and I. There's a Solvita test, and I think we'll talk about those later, but just measure CO2 respiration. You can look at it from disappearance of disturbance. Funny story on that, I got called to go to a compliance review over in extreme northwest Missouri. And the field office, this guy was supposed to be no-tilling with a certain amount of residue, and they said he doesn't have any, but he swears he no-tilled. And I said, well, let's go look at it. And so we went over there, and you could see little, it was in corn, you could see little stalks of soybean residue. There was zero. It was completely bare. But there was an earthworm midden about every 5 or 6 inches. And he had been no-tilling so long, he had such an earthworm population, they completely devoured the residue. Okay? So what does it tell us? It tells us that structure of that food web. Again, you know, if we've got a highly bacterial environment and we're trying to get those ratios, generally we want to try to get it closer to a 1-to-1 bacterial to fungal if we can. It's hard to do in a cropping situation. But that analysis will give us that. It'll give us the volume of biomass. It'll give us the effectiveness of them doing specific things, just like the residue. If we have too much residue, early on, I've had a lot of people say, oh, you know, we're going to have too much residue if we don't do something. If you have good biologic activity, residue will never be an issue. Gives you fingerprints, again, of just ways of identifying it. So, a healthy food web occurs when all the organisms are present and they're functioning. Okay, when you have all of the different trophic levels that we talked about a while ago. When all those nutrients in the soil are in the proper forms for a plant to take up. We had a great discussion about that earlier. While we don't want excess nutrients that are leachable, we do want available nutrients when those plants are taking it up, or when they need it to take up. We want them to hold on to those nutrients. Again, in a really healthy soil, there's not going to be a lot of excess available nutrients. They're going to be made available as the plant says, hey, I need some nutrients. They're going to give off an eggs a day. Turn on specific organisms in the soil and make specific nutrients available. The plant turns those on. The plant is in control. I know we don't realize this or think about it, but it truly is. In the right system, the plant is what's in control. So, it occurs when, again, those ratios are present, when everything else, pH, structure, nutrient cycling, and water, particularly. So the results of that, retention of nutrients so they don't leach, cycling of nutrients into the right forms, the right ratios, also so that we have the right numbers to deal with any predators, okay? Any excess organisms in the soil that can become a predator on a plant. And building structure, you know, so that water and nutrients are available. You know, and that our roots can go down deep. I'll show you a couple of things later in a presentation about root mass and what we can do in a healthy soil. Suppression of disease-causing organisms, protection of plant surfaces, again, predators that are disease-causing organisms. In a good, healthy system, everything is functioning. Everything has a place. We don't want to eliminate anything, okay, from it. We want to keep everything in the proper sequences, the proper ratios. And even toxic compounds. You know, there are bacteria that break down even the most toxic compounds they found. Different organisms are used to break down toxic compounds all over the world in different industries. And so that's what we're talking about. We're talking about living organisms. So how are they getting around? Do you see big legs on most of them? That one was feeding feeding on organic matter. With the exception of earthworms, some arthropods, again, this is why water is so critical. It's not just for the plant. The water is critical for the organisms in the soil to move. If they don't have water, they're not going to move. Okay? That's the importance of it. So let's break it down into each specific one just a little bit. So bacteria, you know, their biggest job is to decompose, break down that material, that organic material. They also, because they can multiply very, very, very rapidly in numbers, they are one of the primary things that when we put nutrients, for example, when we stick nitrogen in there, what's the first thing that grabs it and ties it up? It's the bacteria. Okay? Because they multiply so rapidly, they are the first responders. That's what they do. Boom. They jump in, multiply very rapidly, suck up all that nitrogen, and initially begin that process. Okay? They do a little bit of the glues. We'll get into that in a minute. They filter the actinobacteria. That's the smell, right? That's that earthy smell. They're the ones that give off that earthy smell when you smell that soil. They also they're the low guy on the food chain, right? They're gonna get ate by more critters than anything else. They also have a very low carbon to nitrogen ratio. And we'll talk about that in a second here too. Fungi. Saprophytic, and there are different kinds of fungi, right? Saprophytic fungi are a decomposer. They break down plant material. They help improve organic accumulation, retain nutrients. The middle one here, the bind soil particles with glomalin. There's particular organisms from fungi from the glomal family that they believe give off a secretion. There's some debate about that. But it acts as a glue. A lot of these give off these biotic glues that cause these soil particles to stick together. Okay? Again, they have a fairly low carbon to nitrogen ratio, and they're fairly low on the bottom of the food chain. They're going to be a food for other organisms. They need very aerobic conditions. You saw the pictures a while ago where they were growing through that zone right at the surface, okay? They need very aerobic conditions. That's why the aggregate stability, that pore space, is so critical, is because they need a lot of oxygen, okay? In low oxygen conditions, compacted soils that are sealed over because of tillage, right? Soils that are sealed over right here. No pore space, there's not going to be a lot of oxygen go through that. So, in those low oxygen conditions, you're going to have anaerobic bacteria functioning, okay, that are going to attack and eat that fungi. You got disease-causing fungi that again, they benefit under those aerobic conditions a little bit. There's good and bad of everything. It's about a balance, right? Sloughed root cells. Fungi typically can condense. They take organic matter and they condense it into a denser nutrient chain. You know, they all need a variety of nutrients. Okay, and we're going to talk about that one more in another slide here. Various species can solubilize mineral nutrients, not just one species. So one species does one thing, another species does another thing, right? There's not ever one fungi that does all things. So that's why you need the diversity in there. So here's a picture. We've got a tree root. We've got a mycorrhizal fungal structure here, and then a fungal hyphae. So what part of a fungus is a mushroom? It's the fruiting structure, right? And so to get a mushroom, it literally takes thousands of fungal hyphae coming together to create that fruiting body. So how many times do you see mushroom in a crop field? Not very often. Okay. Once in a while, but not very often. Where do we go find morels? Where do we go mushroom hunting at? In a timber. In a very low disturbance area, not even an area where there's livestock in a timber. So again, what do those things do? Particularly mycorrhizal fungi. Okay, they are one of the most important. They increase nutrient uptake of plants. They work in a symbiotic relationship with those organisms. They increase water uptake. They suppress pest disease. You know, a plant. It depends on what the plant is, but most plants, the soil that they're in, they touch, the roots of that plant touch less than 2% of that soil. If you add a mycorrhizal fungi, some cases they can jump that up to 50% of the nutrients of the water in that soil profile below that plant can now be accessible. You know, exactly what we've got here. A root. And so think about the soil, that the nutrients, the water that's available to this root. Now when you add mycorrhizal fungi to it, how much more is going to be available to that plant? Nutrients, water, okay? They can extend their roots many feet out into that soil by having this, okay? Again, they're very fragile. They do not take disturbance. So what causes them to decline? Again, tillage. Why would mycorrhizal fungi decline in fields that had very high levels of nitrogen and phosphorus? The plants say, I got a lot of luxury nitrogen and phosphorus here. I'm not going to give off any exudates that's going to require the development of that mycorrhizal fungi relationship. Exactly right. Nematode trappers. You know, there are some fungal hyphae that again, these are predators. They're controlling other organisms in that environment. They've got a little ring, the nematode swims through, it constricts. Voila, supper. Protozoa. Taking a step up a little bit. Feed on bacteria and release nutrients. Increase decomposition rates. Okay, we'll talk about that too. Arthropods, you know, mites, the grasshoppers, they're shredders. They chop up residue, they shred it. That stimulates, as they create more edge to those materials, that increases microbial activity. They regulate populations of other organisms as well. So, again, big groups of arthropods. You've got shredders that chop stuff up. Then you've got predators that feed on other organisms. You've got herbivores that are just plant eaters, right? and then arthropods that are strictly fungal feeders. Okay. Millipedes are an example of shredders. They shred, burrow, redistribute. Beetles, ants, again, chew up dead material. And a lot of them, the earthworms are kind of the same way. They chew up dead plant material, but really what are they doing? They're eating bacteria and fungi. That's what they're going for. like a radish. Have you ever dug up a radish that was decaying and rotting in the late winter? if it's good, healthy soil, it'll have a ton of earthworms under it, won't it? Are the earthworms there eating the radish? They're there eating the bacteria that are feeding on the nitrogen being leached out of that radish. Your herbivorous arthropods, again, cicadas, maggots, centipedes, all kinds of other things, again, feeding strictly on plant material. Springtails. That was some of those that jump. They do have legs and tails a little bit. They jump around if you see them under a microscope. They consume bacteria and fungi from root surfaces. Again, just a step up. We're kind of working our way up. We kind of jumped in there with the arthropods, but we're jumping our way up. Non-segmented worms, nematodes. They provide a food source. They're kind of in the middle. They're a food source for other organisms, but then they also regulate populations. They're kind of in the middle. They mineralize nutrients into plant-available forms. And I think one more slide and we'll talk about that. Again, they're high in protein. They have a fairly low carbon to nitrogen ratio. That means they've got a high in nitrogen. It's converted into nitrates. And one more slide and we'll get to that. Thought I had it in right there. Again, nematodes. That's the same slide we just had. Here we go. I thought I nuked that one out. So this is a very, 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 very simple, okay, description of mineralization. If you've got bacteria, everything has a carbon-nitrogen ratio, including me and you, right? So bacteria are extremely low carbon-nitrogen ratio of 5. They've got 5 carbon molecules to 1 nitrogen molecule. So over here we've got a bacteria-feeding nematode that has a higher, and they're not all 10 to 1, but this is just a simple example. So 10 to 1. So he's going to eat this guy based on carbon, right? Based on energy, carbohydrates. Just like you and I do. That's why we're all back there sucking on the Sprite and the donuts, because we're eating based on carbohydrates. Carbohydrates is almost always the limiting issue in the natural world, in the food world. So he's going to eat based on carbohydrates. He only needs 1 of those nitrogen. He's going to eat 2 of these guys. So that leaves 1 molecule of nitrogen left over. That's excreted in the soil as ammonium. Okay, plant available right there. So that's just a simple. Whenever we talk about mineralization, and I realize again, you guys are probably, but a lot of farmers don't understand this. They understand, oh, mineralization, yeah, it's being made available, but how does it do it? Okay, this is the very first step of the process, and then it works its way on up through very similar processes. Higher carbon nitrogen organisms feed on this guy, and then feed on that guy. Earthworms. You know, again, you've got a midden right up here. It's just a little, it doesn't look like much, it's just a little stack of soil and residue right there, piled up. But if you take it and break that crust off, right there's the hole. Okay? And so they bring all that material to them. We'll see a video here in a second. Here's an excavated burrow. They followed it all the way down. We've dug holes. We've seen where plant roots will follow these holes down year after year. Okay. And so, if you see this burrow, why didn't it collapse? Because just like those roots, just like those other organisms, an earthworm gives off, have you ever picked them up? They're slimy, right? They give off a secretion into the soil that helps solidify that hole and stick those aggregates together. Just like the fungal secretions that the fungi give off. Just like the plant exudates that they give off. This helps hold that in place. Dry conditions, they go into dormancy, estivation. You know, if it's dry long enough or cold enough, it'll die in that state right there. If it's moist enough and it has enough energy stored in its body, it will survive that dormant period. You know, we always talk about we've got to do tillage to get rid of residue. You know, and in an unhealthy, continually tilled soil, that's true. But in a soil that has a healthy ecosystem, not only of fungi and arthropods and all these other things, but in a healthy system of earthworms, the earthworms will take care of the residue. Okay? They will pull that residue back. Again, they're pulling it back, not necessarily to eat it themselves, although they will ingest it, but it's to feed on the bacteria and the fungi that are breaking down those leaves. This is the weightlifting earthworm here. Okay? Does it make you guys scared to go out at night? So again, you know, why does people say, oh, I've got to till the soil? Get rid of residue, right? Incorporate that material. But if we have a good, healthy biological system in the soil, these guys will do every bit of that incorporation for us. We don't have to do anything. So, how does management impact that food web? Management impacts it in these ways. Physical disturbance changes the ratio of bacteria to fungi. It increases the bacteria, reduces the fungi. They are the most susceptible to disturbance, okay, the fungi. Which affects availability, which is also affected by availability of water. Crop rotation. As we get more diverse crops, again, different organisms feed on different kinds of plants, grasses, broadleaves, plants that have different carbon and nitrogen ratios, plants that grow different times of the year, plants that give off different types of root exudates. So it takes a diverse mixture. There's no ecosystem anywhere in the world, aquatic, terrestrial, anywhere that's a monoculture in nature. It doesn't happen. Because it knows it takes a very diverse mix of plants. It takes a diverse mix of animals to survive.